Next, we're going to work on factoring things that are a little bit more complicated. Specifically, we want to look at expressions that are in quadratic form. And what I mean by that is that we maybe have a coefficient, a number out in front, and then we have something squared, and then we'll have plus or minus and maybe another number again. And then that same something appears, and then plus or minus a number at the end. So we can have a constant at the end, that's fine. Could be 0 too, that's also okay. So with this very first example, 4b to the fifth minus 11b cubed minus 3b, I actually don't think I have that structure, because what would have to go in the parentheses would be a b cubed, and that means the very first term would have to have a b cubed squared, which is b to the sixth, not b to the fifth. But I can do something. I notice that I have a common factor of b, and you should always watch for your common factor, whether it's the variable that you can factor out, or even if it's just something from the coefficients. That's going to make everything much easier. I don't see that I'm going to get anything from the 4, 11, and 3, so I'll just take the b. So that leaves me with a 4b to the fourth minus 11b squared minus 3. So one thing I noticed there is that I now have the constant at the end, which I like. That's more typical of a quadratic form, not having a b in that last term. The other thing I'm seeing is that now this would be a b squared in the parentheses, and b squared squared is in fact b to the fourth. So it does actually have a quadratic form now. So seeing that the first power is twice as big as the next power is really important for this quadratic form thing. Okay, so what I'm hoping we can do is start to try to go straight to factoring these things, but I will show you how you can use the substitution if that's a little tricky at first. So in this one, I've got to split up the 4b squared, so I'm sorry, 4b to the fourth, so I'm going to choose a b squared and a b squared, and then I need factors of 4, so either 2 times 2 or 1 times 4 or 4 times 1. With that negative 11 in the middle, that's not real big, so maybe a 2 times 2 is looking promising. And then for the last two spots in those parentheses, I need factors of negative 3. So that's going to be 1 and 3. And we get a positive and a negative out of that. Otherwise, the order doesn't really matter since both parentheses have a 2b squared in the beginning. So I'm just going to go 1 and 3. And keeping in mind that one of those can be positive and one of those can be negative, remember we need to check our inside outside. So I see 6b squared and a 2b squared, and it doesn't matter what plus or minus signs I stick on those, it's never going to add up to negative 11. So I don't think I like my 2b squared choice. So I'm going to go back to, and of course the goal is that we get really good at spotting these, and sorry if you spotted that one and I made you watch me do it wrong. I'm going to go back to my choice there and say, well, instead let's do a 4b squared and a 1b squared. And then I'll just try leaving my 3 and my 1 where they are. So now when I check, my outside is 12 and my inside is 1b squared. So that's actually really promising. If I make that a negative 12b squared and a positive 1b squared, then when I add the inside and outside terms up, I will get that negative 11b squared. And then once you've done this step, you can check and see if what's in the parentheses will factor anymore. So for example, this b squared minus 3, if that was a b squared minus 1, I could do even better. I could factor it more. With the b squared minus 3, I can't factor that unless I'm going to allow myself to put square roots in there, which we typically aren't doing with factoring. So just in case you start getting stuck on this or you're finding that really hard to spot, you do have one other option. If you're recognizing that your structure is that you have a b squared squared, and a b squared in the parentheses here, whatever it is that goes in those parentheses, you can actually hide it by doing a substitution. So pick any other variable. I'm going to choose u in honor of Calc 2, where we do a lot of substituting like this. And I'm going to say, okay, I'm going to hide all the b squareds temporarily by replacing them with u's. So this b out in front is just fine. But the b to the fourth is actually a b squared squared. So we're going to make that b squared a u and say that's just a u squared. And then we have the 11b squared, replace that b with a u, and then we have the minus 3. And then you can factor, it's the exact same numbers, so I actually already know how it's going to work. But you can factor from there without having the extra powers that potentially might confuse you a little bit. And this was a 1 minus plus. Okay, so I think that was our factoring. The one thing you have to be really careful about here is if you're going to substitute in this u, I didn't ask any questions about u. That's a variable that you made up to do the problem. Make sure you plug the b's back in. So we'll replace that with a 4b squared plus 1 and a b squared minus 3. Okay, so optional, you can substitute or not, but that's always something that you're allowed to do if you'd like to just take away some of the confusion. Okay, so this second one, and again, mostly we're going to focus on polynomials, but I want to throw in a few of these things here and there that aren't necessarily polynomials, so you can see this trick will work on all sorts of different types of expressions. Again, what's key is that your structure has to be something squared, and then that something shows back up again. So if that's going to work here, my something, let me switch to my pen, has to be b to the negative 1/3. And to check myself, I'm going to say, okay, well, what is b to the negative 1/3 squared? And it is, in fact, b to the negative 2/3. So that's looking really promising. So again, we can try to go straight to splitting this up. If it's complicated, we can substitute, but I could make that a b to the negative 1/3 and another b to the negative 1/3. So you just have to split, whatever your power is, you have to split it in half to make those two equal. And then we're looking for, since this is just a 1 out in front, we can use the really old trick, factors of -6 that add up to 1. So we're going to want the 2 and the 3 for sure. And if we want to get a -1 in the middle, I think I said that wrong, factors of -6 that add up to -1. We're going to need a -3 and a +2. So give that a try. But again, if you're getting kind of stuck on that, let me wipe this out. We do have the option of going back to the method of trying to hide the extra mess that's showing up here. So if we're recognizing that the b to the negative 1/3 needs to be in parentheses, that's what we're going to substitute out. And again, any letter except for B is fine. Maybe not any. E is probably not a great idea because it represents a number. I is probably not a great idea because it is our imaginary number, which you probably haven't had to worry about if you've taken all your pre-calc here. Okay, but we're going to substitute and we're going to replace all the b to the negative 1/3 with w. So we can kind of compare down to below, and we're going to say, okay, that's going to become a w squared, and it was just a 1 out in front. And then a minus w, also just a 1 out in front, and a -6. So just replace all the b to the negative 1/3, and then it becomes a standard quadratic that we're trying to split up. So we need a w and a w, and then factors of -6 that add up to -1. So that should be a -3 and a +2. And always you just do that inside-outside check. So -3w plus 2w does in fact equal -1w. So I think we're on track. Okay, and then again, last step is just to rewrite that in terms of b. You are welcome to make that 1 over b to the 1/3 so that you have positive exponents. You can make it 1 over the cube root of b. I'm just worried about the factoring part right now. So as long as you're getting the factoring part, I'm going to be happy about this. Okay, just one more. This one actually is polynomial, and it's a little bit different trick that we're going to use here. I don't even know if this counts as quadratic form, even though I said that. In fact, I know it does not. But another trick that can be really handy when you have an even number of terms, so 4 terms or 6 terms, usually it's 4 that we'll try this on. Sometimes you can rearrange and group pairs together. So in this case, I'm making it easy for us because we're not going to use a ton of this, but I do want you to know about it. We can pair the first two together and factor out a common factor from just that pair. So I could take out a 2 and an x squared, and it would leave me with an x minus 3. And then from the second pair, this is a little tricky with that minus in front of the 4. We have to factor that minus out. So we're dividing out -4. So it leaves an x here. That doesn't usually throw people. But you have to divide the 12 by -4. So you're actually going to get -3. And remember, the best check is just to distribute that 4 back through. And you should be able to spot if you've got the signs right. Okay, so here's when this is powerful, because you could always try doing this and it may or may not be helpful. It's really helpful when you end up with a common factor out of the deal. They both have this x minus 3 involved. So this is now split right there into 2 different terms that share a factor of x minus 3. So we're going to remove that factor of x minus 3. So this is greatest common factor, factoring again. And we're left with a 2x squared minus 4. And actually, I'm spotting now, I could have done even better. There was also a common factor of 2. So let's go ahead and take that and put it out in front with the x minus 3. And say, really, it's an x squared minus 2 in here. Okay, and again, check this. If this was an x squared minus 4, that's actually a difference of squares we'd be able to factor. So if you can factor more, do factor more. Otherwise, those are the 2 big factoring tricks we're going to use for some of these messier things. So give it a try and just let me know if you run into any trouble with these.